All right, the main idea when we're shifting parent functions, right? The main idea, of course, is functions, which is a machine. You put things in and get things out. Okay? The nice thing about that idea is that no matter what type of function it is, some things about those machines all work the exact same way, right? So that's one of the things I'm really trying to drive in this section, is for you to understand that even if you don't recognize a function, like I don't think any of you guys recognize what this function is, it's called a step function. You don't know what the shape is at all on a graph, right? You don't even know how it works, I haven't taught you that. But the movements that we can do with all functions are the same. That's the key idea, okay? So I want us to take a look at just the general form. If we have a function, then we can have a multiplier up front, and then we have some sort of operator. And that could be a square root, absolute value symbols, a double bracket like that. Could be an exponential like this, or even a fraction. There's different operators in math, okay? So we have A, and then we have some sort of operator. I'm just going to use like parentheses just for a general operator. And then we have X, and then you can do something, I'm going to say minus H, and then you can do like plus something outside, I'm going to just use K, okay? So this is like the general form for all functions. And so a number out front of any of these does the same thing. A number off the back, like K here, for any of these does the same thing. Okay? And a number inside with the X does the same thing. Okay? So that's the key idea. So let's take a look at these specifically. Should I leave this up, this general form thing? Does that help? Okay. Yeah, I can leave that up. It's kind of overlapping the work, but all right. So now let's take a look at this problem specifically. The number outside, it's a multiplier of what? 2. What does it multiply by 2?
Everything else.
The heights. It stretches the heights. So I say heights are stretched vertically by a factor of 2. Okay? A factor means multiply. So the heights are doubled. All the heights everywhere on the graph are doubled. Okay? So it's stretched vertically. That's what the 2 does. Alright? This -1 is kind of in the same position. It's a different type of function, but it's the same position, right? It's where A is, right? So what does this -1 do?
It mirrors.
Yeah, that doesn't change the heights because multiplying by 1 doesn't stretch anything or compress anything. But a negative out front, a negative A, does flip it down. It mirrors on the x-axis. Okay? So that one mirrors. Okay? We don't have an A value here in front of this one. We do have an A value here in front of this one. What does that do?
Multiplies by a factor of 3.
Stretches the heights by a factor of 3. Okay? Now, I do say something about heights on this one, coming back to this. Because this is a 1/2 rather than a whole number. And so that does compress the heights when you have a different base on the fraction. Right? So, heights are compressed by 1/2. I was going to write 1/2 and then forgot how to spell half. It just didn't look right, so I just wrote 1/2. But also the ramp is declining, because these look like a ramp. And instead of a ramp going up like this, a 1/2 has a ramp going down like this. Okay? So that one, even though there's not an A out front, the heights are impacted by the base here, okay, of the exponent. Right? So that kind of handles, for all these problems, handles kind of like the A. Now let's look at the H. Now it says X minus H. So if I have a +3 here, what does the H do, first of all?
It changes the direction horizontally.
Yeah, it's a horizontal shift. Okay, so no matter what the function is, it's a horizontal shift if it's in with the X, right? So this has a +3 in with the X. Which way does it shift?
Left.
Yeah. Left 3. Okay, so left 3. This one has a 2 in with the X, the +2. Which way does it shift? Left 2.
Just the opposite of what you would think.
Yeah, exactly. It's the opposite of the way you'd think it would go, because usually pluses are to the right. But a plus here is actually, because this is the formula, x minus h. So if h is negative, then the two negatives make a positive. So when we have a plus 3 here, it's actually x minus a negative 3. The shift is negative 3. All right, so yeah, it's opposite the way you think it goes, so a plus 3 goes to the left, toward the negatives. All right? This one goes to the left 2, toward the negatives, so left 2. What about this one?
I have a question.
Yeah.
How come, or what happens when it's cubed? What is this?
It actually doesn't really matter, that's just the operator. It does have a different shape, but it doesn't matter, when we're trying to figure out what the 2 does, it doesn't matter what the operator is. Like, it's just, whatever shape it is, left 2.
Yes.
Okay, so you may not know this shape. If you're curious, the shape is like a parabola on one side, and then an upside down parabola on the other side. That's what the shape looks like if you once you get to know that function. But knowing what the function shape is isn't the point of this question. In fact, I tried to pick functions that you may not be a little, very familiar with or may not know at all, because I want you to focus on not what the operator is, but what is true about all functions. Right? Good. So this one here, is this shifted left or right?
Left.
Shifted left because the 1. See, the 1 is with the x in the exponent space. The exponent is the operator here. Right? This is where the x is. It's the operator. Right? So yes, that is shifted left 1. What about this one?
Left 5.
Left 5. And you guys, this double bar is called step function. And the shape is a rounding function, and it looks a little bit like steps. Like this. Okay? You had no idea maybe previously to this class what that is. But that's the point. Once you understand how functions move, it doesn't matter if you know the shape or not. You will in the future. But it doesn't really matter. You can still move. You can still see what the moves are. Right? What the transformations are. Okay, so this is left 5. Alright? So that takes care of H up here. The left-right shift. K, this one's probably the easiest. Right? So we're finishing up. Starting
Down
with this.
7.
Down 7?
Mm-hmm.
Yep, so it's intuitive. Does this one shift up or down?
No.
No. Does this one shift up or down?
Nope.
Nope. Does this one shift up or down?
Yep, up 8.
Up 8. So that whole staircase is just moved up 8 here. Okay? Yeah, so that K at the end, that's probably the easiest one to do. Because it's really intuitive. Positives up, negatives down, and it's a number that's not included with the X. It's off the end. Right? And that kind of covers, like, function shifting. So on the quiz tomorrow, I may have functions here that you do not recognize. But you should be able to recognize whether it shifts left or right, or up or down, or if the heights are stretched or compressed. Alright? Yeah.
So the exponent, like the 3,
Yeah.
that doesn't matter in like changing it in any way. It just changes the shape of it.
Yeah, an exponent of 3 makes the original shape, the parent function, look a certain way. But once you have that shape down, when you shift it, the shape doesn't change. Unless you're stretching heights, or compressing heights, then the shape will maybe change in height, but still it's the same basic shape. Good question. All right, so here's this last question. I asked you to graph the functions on the same graph. So 3 different functions on the same graph. And it shows kind of a transformation because I started just with a basic square root. This is the function you've had the most practice with, the square roots. Recently. You probably had more practice though with lines, right? Straight lines. But recently. Okay, so this is a square root. So I did that just in like pencil or I guess red pen. Okay. And then I labeled it. And it goes through, 1, 1 and 4, 2. Right? So that's your paragraph. And then I graphed this one here, which is a shift which direction? Left 3. There's a lot of left shifting on this quiz, isn't there? I didn't do any right shifting. Tomorrow you can expect left or right. Okay. But you guys have left shifting down if you've seen this quiz, right? So this is just shifted to the left. So I just take the shape, moved over to the left. That's the blue graph here, and I labeled it. And then this one here. What's different about it?
It is a vertical stretch of 2. And it's
Vertical stretch by 2, so this is just without stretching, and then this is a stretch by 2. So this height here is doubled, and this height here is doubled. Okay?
How come you wrote it without double
Just because it's kind of an intermediate step to get me kind of there. I think I just saw that this was shifted up 4. I just shifted it up 4 without noticing the 2, and I'm like, oh yeah, then I have to expand it also. So this is just kind of an intermediate step maybe to get to this.
I see.
So I get the right location and then I stretch it. So that's why I kind of hashed this out and then labeled it, even though I wasn't asked to show this one. So, you know, you probably don't have to do that. I mean, you could just show this one here. But, so this is like moved over and then up and then stretched. Okay? So up 4, that's of course where these purple graphs start, is up 4. Alright? So this shows like the transformation steps. Like this is parent function, moved over, moved up, and then stretched. Okay?
Oh.
Good.
Yeah, I'm good.
Any questions? Or I should say, what questions do you have? Not any questions. There's always questions we could ask, right? You can stop recording if you're